Hello everyone, and welcome to this webinar. My name is Stefan Budo. I am a Microsoft Azure MVP and a solutions architect working at Vigilant IT based in Sydney, Australia. Today, I will take you through discussing OMS with a focus on automation. I'll start with some slides to give you a good overview of Azure Automation, but we'll then spend the majority of this webinar showing you, through a series of demonstrations, how the power of Azure Automation can make your IT life easier. I have a lot of exciting things to show you, so let's get right into it. What is OMS? OMS stands for Operations Management Suite. It gathers data from servers throughout your IT infrastructure and consolidates that data in a single management interface. That data might include diagnostics, log, performance, or alert data from both Windows or Linux computers. Alerts in OMS can automatically inform you by sending an email notification, and OMS can auto-remediate issues with Azure Automation Runbooks. What do you get in OMS? You get insight and analytics to gain immediate insights across workloads and tap into operational intelligence when it matters to explore, analyze, and take action faster. Automation and control, which enable consistent control and compliance, allowing you to deliver continuous IT services and remediate issues quickly and at scale. Security and compliance, of course, respond faster to security threats, identify emerging threats to protect your critical data and workloads. And finally, protection and recovery. Ensure availability of your applications and data with a simple, automated data protection and disaster recovery in the cloud. In this presentation, we're going to focus on the automation and control component of OMS. But what exactly is automation? When we think about automation, we usually refer to some repetitive tasks that used to be done manually, that we now have asked a computer to do for us using workflows or scripts. For example, think about how you used to call help desk to reset your password, while now you might simply go on your intranet site and click on the link. It's correct to think of automation this way, but I'd like to extend this and define it as a group of processes and services that will simplify the management of your IT environment, allowing to further control and optimize your systems and processes while increasing their efficiencies. This already answers part of the next question, which is why you need automation. Well, here's a few examples. With automation, you will simplify the management of your IT systems. You will enable your IT staff to focus on work that adds business value as opposed to repetitive tasks. Human error in manual activities will become a distant memory. And you will ensure consistency across existing and new systems. All this will lead to improved service reliability, while lowering your costs and increase your return on investment. If we take a look at the life cycle of your infrastructure and applications, from building and configuring, monitoring and protecting, to security and governance, the automation and configuration piece is a major contributor through the entire life cycle. During the building and configuring phase, it ensures consistency across your systems, along with ensuring they are correctly integrating with other systems. Automation also helps you during the monitoring and protecting phase by, for example, auto-remediating problems or ensuring a workload is automatically added to your backups. And finally, it even plays a role during the securing and governance by automating the installation of security updates missing on a server, for example. Knowing the what and the why, we must of course now ask, how? What are the platforms Microsoft has so far put at our disposal to start implementing automation? Orchestrator was the first platform offered. It is a workflow-based engine that gave you a simple visual drag-and-drop authoring experience. It integrates with a lot of different systems through the use of integration pack, but presents a set of challenges and restrictions such as parallelism, when the result of an action would return multiple values, restart behaviors when initiated from a runbook, the use of a 32-bit PowerShell engine, and no checkpoints. In addition, Microsoft will no longer continue developing this engine. Next came the Service Management Automation, or SMA, which is a PowerShell workflow-based engine. This fixed some existing problems such as the parallelism, checkpoints, but in using workflows compared to PowerShell scripts, introduced some new restrictions such as unsupported activities, scope of variable, deserialized objects, etc. Although great automation platforms, these set of tools were developed to manage your on-premises environment. However, the next challenges most businesses will be facing is the hybrid world. As you are starting to extend your data center to the cloud, Azure or other, the life cycle of your resources is still the same. So now you need an automation and configuration platform that will not only solve the problems of the existing tools, but also work across both on-premises and cloud-based resources. The new Microsoft OMS Automation platform does exactly that. You can access an easy configuration console in the cloud that will allow you to manage both on-premises and in the cloud automation processes. Securely centralize automation assets such as variables, credentials, connections to other systems. The automation service was built with a major focus on keeping your development investments safe. Any existing PowerShell scripts or workflows can be imported and used as is in the platform. And if you are using Orchestrator today, you can convert those workflows so that they will run in OMS Automation. This is an highly available and reliable process and desired state automation system that simplifies cloud and on-premises management and will deliver faster automated remediation. You can orchestrate your deployments, ensuring true consistency across all your systems. Of course, it will eliminate manual, simple or complex, repetitive IT operations, such as user provisioning, password resets, or more complex tasks. Repeatable steps, processes can now be automated by the Azure engine, so you free up your staff for better things. This can also ensure that your system remains up to date without any human interaction. Scalability becomes a standard as your resources will be automatically assigned to where and when it's needed. And finally, security and governance is ensured by enforcing your configurations and policies upon existing or newly deployed workloads. All this across any platform, any cloud. Now that I've introduced OMS Automation, let me quickly go to the Azure Portal and give you a quick tour. Okay, so I've logged on into my Azure account and you can see the portal, which by now should look familiar. Along with all the other Azure services, we have our automation accounts. The automation account will contain all settings related to your automation along with runbooks, DCS configuration, etc. It is very easy to create an account. Just click the Add button and then enter the request information, name of the account, which has to be unique, the subscription it's going to be created in, the resource group we want to use, and the location, etc. I've already created an account for this demonstration, so let's drill into it to see what's in there. The first thing that appears is an overview of the account. Here you can, at a glance, see how many runbooks you have, how many assets have been created, if you have any hybrid worker group, information related to desired state configuration, which we'll see in more details later on, and an overview on job statistics and the settings related to the account. In the settings, the first thing I wanted to point out was the pricing tier and usage tab. If we look at this setting, we notice that Microsoft is giving you a free usage of the automation service that includes 500 minutes of automation, along with managing 5 DSC nodes. So you can get started with Azure Automation for free effectively. I've also mentioned earlier that you can do source control with GitHub. This is where you would configure the connectivity of GitHub should you want to enable it for your account. Now going back to the overview, let's go into the assets. From here, you can create, modify or delete any of your assets. Assets are various resources that are globally available to be used in or associated with your runbooks. We have different types of assets. Variables. Variables are values that are available to all runbooks. They can be created, modified, and retrieved from the Azure Portal, Windows PowerShell, or from within a runbook. They can be used in runbooks to define frequently used settings such as directory path to common files, server names, or other strings. Variable settings store strings, boolean, integer, or date and time information that can then be used in a runbook. They can also contain complex objects, although you must use PowerShell to do this as it cannot be done through the automation UI. Connections. Connections define the information required to connect to a service or application from a runbook. The different types of connections you can create are defined by the integration modules imported into automation and typically include such information as username and password and the host or service URI to connect to. Credentials or certificates are either a username and password combination that can be used with Windows PowerShell commands or a certificate that is uploaded to Azure Automation. The properties for credentials are stored securely in automation and can be accessed in the runbook. Schedules are used to schedule runbooks to run automatically. This could be either a single date and time for the runbook to run once, or it could be a recurring schedule to start the runbook multiple times. And finally, the integration modules. Runbooks rely on PowerShell commandlets to access different systems, services, and devices. An integration module is a package that contains a Windows PowerShell module and can be imported into Azure Automation. Let's have a quick look at the credentials. You can see here I've already created a credential to access my Azure account with a username and password, but I wanted to show you how easy it is to create a new asset. So to do so, we just click Add Credentials, enter a username and a password, and click Create, and that's it. These credentials can now be used securely throughout your runbooks. I'll show you how in a later demo. Going back to the overview, let's have a quick look at the runbooks. From here, you can manage all your runbooks, including importing them from the Microsoft library. We'll come to that later, along with how to create a new runbook. You can now also link the automation account with your Operations Management Suite console and see all the related OMS information by going into the Workspace tab. From here, you can effectively see an overview of what's currently associated with your OMS workspace. Let's have a quick look at the Jobs tab. Everything you start through your automation account, runbooks, etc. is a job-based action. A job will be started and you can monitor the progress of it in this section. If you click on a specific job, you'll see the information related to that job. The status, the inputs that we're giving to the job, but also a live output console, allowing you to follow a running job step by step in case of debugging, for example. And finally, if we go back to the overview, you can see the configuration and DSC nodes for the account. We'll drill into that at a later demo in this webinar. That's a quick overview of what Azure Automation looks like in the portal. Before we dive into some more demonstration, so I can show you what hybrid automation can do, let's have a look at the different type of automation engines we can use within this new platform. The first one is what we refer to as PowerShell as a service. In prior versions, you would have had to create a PowerShell workflow in order to use the automation service. Although you can still use workflows, you no longer have to do this, as this engine truly allows you to run all your existing PowerShell scripts without any modification. There is no need to set up any infrastructure, as the engine is running as a service in the cloud. It will not only scale automatically, but you can rest assured that it will remain up to date with the latest feature. And because it's available throughout the existing Azure data center location, you can even separate policies based on local compliance. You can now use PowerShell for your automation like you were already doing on premises. But in addition, you now get all those added benefits such as centralized secure store, reliability, scalability, and historical analysis where you can view things like job results, code history, and you can also create what we call webhooks, which effectively transform your PowerShell runbooks into web services. I've mentioned before that this was a true hybrid system, but how would you use the Azure engine to run PowerShell runbooks on your local servers? Runbooks in Azure Automation cannot access resources in your local data center since they run in the Azure cloud. The hybrid runbook worker allows you to run runbooks on machines located in your data center in order to manage local resources. The runbooks are stored and managed in Azure Automation and then delivered to one or more on-premises machines. You can designate one or more computers in your data center to act as an hybrid worker and run runbooks from Azure Automation. Each worker requires the Microsoft Management Agent, which is a connection to Microsoft Operations Management Suite and the Azure Automation Runbook environment. OMS is only used to install and maintain the management agent and to monitor the functionalities of the worker. The delivery of the runbooks and the instruction to run them are performed by the Azure Automation engine. There are no inbound firewall requirements to support hybrid runbook workers. The agent on the local computer initiates all the communication with Azure Automation in the cloud. When a runbook is started, Azure Automation creates an instruction that is retrieved by the agent. The agent then pulls down the runbook and any parameters before running it. It will also retrieve any assets that are used by the runbook from Azure Automation. Now that we can use Azure Automation as our PowerShell engine, how can we author and control our scripts? There are a few methods that can be used. The Azure Portal. You can create or modify scripts through the use of a text editor or a visual drag and drop based system. Although not optimal, this interface can be used from anywhere, which is a huge advantage. You can also use PowerShell ISE to author, test, and publish your scripts from your local computer directly into the Azure Automation. So you can create and fully test your PowerShell scripts locally before you upload them to Azure to be ran on the automation engine. No matter where you create or modify your scripts, GitHub can be used as your source control, ensuring versioning, code sharing, and all the other great features coming from GitHub. Before I continue with the second type of automation engine, which is the desired state configuration or DSC, let's go to the Azure Portal where I can show you what you can do with Azure PowerShell Runbook automation. Now, before I get back to my Azure Automation account, let me quickly go to the Virtual Machine tab so I can show you that one of my demonstration VM, Demo02, is currently running. This is important as we will use this later in this demo. Let's go back to the Automation tab and drill into our automation account. As we've seen in the previous demo, we get to the overview for the account. This time, we're going to create a new PowerShell runbook using the built-in portal editor. For this example, we'll use PowerShell to shut down the Demo02 virtual machine I've just shown you. To get started, we click on the Runbook tile, which is showing us a list of all existing runbooks. Then the Add a Runbook button. From here, the only thing we need is the name of the PowerShell runbook, let's call it Stop My VM, and the type of runbook. As I've described before, you can either create a PowerShell script through the text or the graphical editor, or create a PowerShell workflow. In this case, let's select the PowerShell script so I can show you that it is exactly the same thing as an on-premises script. As soon as the runbook is created, we found ourselves in the text editor. Notice on the left side that you have a list of all available commands based on which modules we've imported, as well as other runbooks and existing assets, such as the credentials I've created in the previous demo. So let's get started on our script that will shut down my Demo02 virtual machine. First thing is to define the input parameters, in the same way as we would for any other PowerShell script. We'll need 3 mandatory ones. One for the Azure credentials to connect to our account. We'll get this from our assets. One to define our subscription. And finally, one for the name of the VM that we want to shut down. Next, we use the get automation ps credential command to grab the credentials from the asset. We then authenticate to Azure through Active Directory and get the name of our Azure subscription that matches the name given in the parameters. Let's select that subscription with the Select Azure Subscription command. Once the selection is done, we use our credentials and subscriptions to access the Resource Manager. Using the Resource Manager, we get the information about the virtual machine we want to shut down, in this case using the last of our parameters, which is the VM name. We also grab the resource group associated with that virtual machine. And finally, we send off the Stop Azure RMVM command to stop the VM. That's all we need. Let's save this and go to the test pane, where we can test and debug our code. You can see that the script asked us to enter the defined parameters. The Azure credential name, which is the name of the asset that contains the Azure username and password. The subscription name, which is the name of the subscription the virtual machine is in. And finally, the name of the virtual machine. These 3 inputs will be given to our scripts when we press the Start button. Once we press that button, notice in the console on the right, the job status changes from queued to starting to running. Our script is now executed on the Azure Automation Engine, and any PowerShell output will appear under the status console. You can see the end of the execution as the script is completed and returns the final result, which is successful. So if we now have a look at our virtual machines, we see that demo 02 is actually turned off. Although this is a very simple example, I wanted to show you that there was no difference between doing a PowerShell script for your on-premises environment or for Azure. Let's go back to the automation account, and now that I've tested our PowerShell Runbook and we're happy it works, publish it. This will make this Runbook accessible to be started from the portal, through scheduling, or via webhooks, effectively making it as in production and ready to use. As you start creating more runbooks, you'll quickly notice that the portal editor, although good, has limited functionalities. So let me show you how you can use your local PowerShell ISE editor to create, modify or delete Azure PowerShell scripts. If I launch ISE, you'll notice that I have installed the Azure Automation add-on. This add-on can be easily downloaded from Microsoft and installed for free. Once installed, we see the Azure Automation tab and can configure where our local copy of our scripts will be located. Then, if we log into our Azure account, you'll see all the subscriptions associated with that account, along with the automation account within the selected subscription. Now that we are connected to the automation account we wanted, let's click on the Runbooks tab. And the first thing we notice here is the new script we just created to stop our VMs. We can download a local copy of this script and edit it if we wanted to, but let's take it a step further and create a new script to this time start our virtual machine. We click on the Create New button, enter the name of the script, this time Start My VM, and hit the Script button. This will create a local copy of the script. Since we've already done most of the work, let's copy-paste the script we've created before and just change the last line from Stop Azure RMVM to Start Azure RMVM. Let's save it, then upload our local copy to Azure with the use of the Upload Draft button. Now that this is uploaded to Azure, we can test the draft from here or publish it. Since we know it's going to work, let's do that. When the publishing is completed, let's go back to the Azure Portal and refresh the list of runbooks. And There it is, a new Start My VM script already published. We can now simply select it and hit the Start button to launch it. In the same way as the other script, we'll need to enter the required parameters: the name of the asset containing our Azure credentials, subscription name, and the VM we want to start, in this case Demo02. Click OK to start it. Note here you get an overview of the running job with the statuses and an output console, similar to the debug console we've seen before. As soon as the job is completed, it will return the PowerShell output. Now, our Demo02 VM should be started, so let's go have a look. And here it is, now it's running again. Unfortunately, we're running out of time for this demonstration, but I wanted to quickly show you the ability to create scripts through the graphical interface this time. Back in our automation account, let's go to the Runbooks and this time click on an existing one. This will open the graphical editor, which, as you can see, is a block diagram of the PowerShell script. Each block will execute, in your defined sequence, a PowerShell command through the use of links. To define what a block does, you can simply click on it and enter the appropriate parameters related to the command at hand. The engine will then translate this block diagram into a PowerShell script. Finally, before we conclude the demo, note that Microsoft has created a gallery of pre-created scripts that you can browse and import into your Runbook library. You can access this gallery with the Browse Gallery button and either search or browse through the existing scripts or workflows. Select any you want and import them. Okay, so we've seen how Azure can help you create and maintain PowerShell scripts to automate pretty much anything in your environment, either on premises or in the cloud. Now, let's have a look at the other Azure automation engine, which is DSC, Desired State Configuration. DSC is a new management platform in Windows PowerShell that enables you to deploy and manage configuration data for software services and manage the environment in which these services run. DSC provides a set of Windows PowerShell language extension, new Windows PowerShell commandlets, and resources that you can use to declaratively specify how you want your software environment to be configured. It also provides a means to maintain and manage existing configuration. Here are some scenarios where you can use DSC resources to configure and manage a set of computers, also referred to later on as nodes, in an automated way. You can enable or disable server roles and features, manage registry settings, manage files or directories, starting, stopping, managing processes and services, managing groups of user accounts, deploying new software, manage environment variables, run Windows PowerShell scripts, fix a configuration that has drifted away from the desired state, discover the actual configuration state of a given node. So you see, there's multiple of ways of using desired state configuration that can help you manage your environment better. DSC is also now fully integrated with Azure Automation. With Automation DSC, you can now ensure that your configuration management is automated, ensuring consistency across your servers, on premises or in the cloud, across Windows or Linux. If you already have DSC in place, you can import the configuration files, compile them and easily distribute them to new or existing servers. It is also very easy to create new configuration files and get started today with this easy automated configuration tool in Azure. And because DSC is part of the Azure Automation Engine, you can also benefit from all the reporting on jobs, compliance, rich UI, API, and more. So here's an overview on how the DSC lifecycle would look like in OMS Automation. You first declare your configuration. In this case, we define that the nodes should have the web server role and the web ASP.NET 4.5 installed. We then take this configuration file and compile it. which create what we call the node configuration MOFs document. And finally, we just assign this to one or a group of nodes. The automation platform will then check on those nodes if the web server role is installed along with the ASP.NET feature. And based on what we have defined, we'll either report back the results or remediate by automatically install the roles and feature on the node with no manual interaction required. Again, the nodes can be located on premises or in the cloud. Now that we have a better understanding of the Azure automated desired state configuration, let's go back to the Azure Portal so I can demonstrate how it works. But before I get to the portal, I've connected to my Demo O2 virtual machine so I can show you that it is a vanilla Windows 2012 R2 server with no roles or features installed on it yet. In this demonstration, let's assume that you have a web server farm and you need to add this server to the farm. In order to be ready for deployment, the server in this scenario needs IIS Web Server and ASP.NET 4.5 installed so it can be added to the web farm. Let me show you how we can do this without any manual interaction through the use of DSC. Back in our Azure Automation account, in the overview, we see the DSC configurations and DSC node styles. The first thing we need is to import a DSC configuration. As mentioned, this is a configuration file that will be applied to one or more nodes, and in this case, we'll get DSC to install the necessary components on the server if they are not there yet. I've already imported and compiled a configuration file called Web Service. This was a simple task done through the Import a Configuration button. If I click on it, you can see that the only thing we require is to point Azure to an existing local configuration file and to name the configuration. In our case, I've named it Web Service. After the configuration file is imported, you can then compile it with the Compile button, which I've already done. Let's take a closer look at the configuration file. As you can see, this is a simple configuration file that will instruct the DCS engine to check for the presence of the IIS web server role, and will also check for the presence of the ASP.NET 4.5 feature. We'll see later what the engine does with this information if, for example, the role or feature is not present and the checks fails. Now that we have a configuration file imported, compiled and ready to go, we go to the DSC nodes section to not only add the node to the system, but also apply the configuration to them. I've already set up a virtual machine called Demo O1, which in this scenario is part of my web farm and also needs the web service and ASP.NET 4.5 installed. You can see that currently the node is compliant, which means the checks for those components is successful. If we click on the node, you can see the history of the checks. Let's go and add our Demo O2 machine to this environment. From the buttons above, you can either add a server that is located in Azure or on premises, as we discussed during our presentation. Since our Demo O2 VM is located in Azure, let's pick that option. The first thing is to select which virtual machines we want to target. In our case, it will be our Demo O2 server. Next, we'll need to tell the system what configuration file it should use to check the server. In our case, we want the web service configuration we've created before. The node configuration you specified will be applied to the VM at intervals specified by the configuration mode frequency. And the VM will check for updates to the node configuration at intervals specified by the refresh frequency. The next option specifies how the engine actually applies the configuration to the target nodes. Choices are Apply Only, DSC applies the configuration and does nothing further unless a new configuration is pushed to the target nodes or when a new configuration is pulled from the server. After the initial application of a new configuration, DSC does not check for drifts from a previously configured state. Apply and monitor. This is the default value. The engine applies any new configurations. After initial application of a new configuration, if the target node drifts from the desired state, DSC reports the discrepancy in logs. Apply and autocorrect. DSC will apply any new configuration. After initial application of a new configuration, if the target node drifts from the desired state, DSC reports the discrepancy in logs and then reapplies the current configuration. Let's select that one for our demo. Then select if the system should overwrite previously downloaded configuration file and if the server can reboot if needed while applying a configuration. Beware that if this option is selected, the server will not warn you before rebooting. And finally, specify what happens after a reboot during the application of a configuration. Either continue the configuration, to continue apply the current configuration after a machine reboot, or stop configuration, to stop the current configuration after the machine reboot. Let's hit OK and let the magic happen. The server will now get registered with the DSC engine. Then the configuration will be pushed along with running that configuration. Since the web service and ASP.NET 4.5 are not installed and we selected the option to apply and autocorrect, DSC will deploy the role and feature to the server automatically. This will take some time, but through the magic of recording, we can fast forward through the process. Now that the process is completed, we can see our demo O2 VM is now appearing in the DSC nodes and is marked as compliant. Which means if we go to our server console and look at the server manager, we can now see that there is an IIS component installed. If we drill further in the roles and features of the server, we see that DSC has auto-corrected the problem by installing the default web services along with the ASP.NET's 4.5 feature. In our scenario, this server is now ready to be added to the farm without any manual component installation. DSC has ensured that the appropriate roles and features are installed consistently throughout the farm. If for any reason those services would be uninstalled, DSC would reinstall them at the next check. Again, due to time constraints, this is of course a very simple example. DSC configuration can be extended to suit very complex deployments, security needs, etc. etc. So, where to start from here? An OMS proof of concept can be an easy introduction to Azure Automation, but also any other features within OMS that we've covered or will cover during our webinar series. And if you qualify, you could take advantage of the OMS Accelerate offer to have Microsoft fund the OMS proof of concept so you can see for yourself the advantages of the operations management suite in your data center. For more information, simply email us or visit our website. Alright, that's it for now. Thank you very much for your time and don't miss out on our next webinar where Azure MVP Mark Keen will talk about OMS security. I hope you enjoyed this presentation and that you'll soon try out OMS.